Good morning, good afternoon, or good evening, depending on where you are on the globe today. Welcome to Managing Facilities Through the Pandemic, Energy Savings Tips for Facility Operations. We have a few people still signing on, not surprising. We've got a wonderful showing today. So we're going to pause momentarily to allow everyone to get settled in. And in the meantime, we'll keep you busy. We would like to learn a little more about you. Please tell us about your role in your organization. And we'll be back in a minute to get the webinar underway. We'll give it about another 10 seconds here. Welcome back to today's webinar, Managing Facilities Through the Pandemic, Energy Savings Tips for Facility Operations. I'm Ed Armstrong, the Executive Director of the Energy Management Association, and I'll be serving as your moderator today. It's worth noting that EMA is actually one of 3 affiliate trade associations. Also in the family are the AABC Commissioning Group and the Associated Air Balance Council. Today's event comprises elements of all 3. Webinar co-sponsor ETC is a member of our ACG group. ETC's affiliate Building Fit is an associate member of EMA, and AABC's executive vice president will be serving as a panelist today. So it's kind of a family affair. Before we begin, let's go through a few housekeeping items. Continuing education units. I know many of you are interested in this, and I will tell you that all of the attendees of today's webinar receive an AIALU or learning unit. You get it automatically by virtue of being properly registered. We will be sending you a certificate of attendance, which you can use for your recertification needs. We welcome questions. There's a chat box in the lower right for your submissions. Last, we will be distributing to all registrants a list of resources containing valuable insights beyond today's webinar. Speaking of today's webinar, the COVID-19 pandemic hit us all tragically and unexpectedly. People had little time to prepare their organizations or facilities for the changes we're experiencing today. In fact, many were forced to make things up on the fly. This webinar will discuss several practical ideas for saving energy in unoccupied or near empty buildings during this time of uncertainty. These energy saving ideas and strategies are focused on facility operations during the pandemic. In addition to discussing how to successfully manage unoccupied buildings to minimize energy costs, we will discuss golden opportunities created by this unexpected shutdown. Facility teams can find and capture specific energy saving opportunities that will improve building performance and lower energy costs long after this pandemic has ended. So let's get started. Our first panelist brings a ground level perspective. Let's welcome Brian Conrad from Prince William County Schools. Brian, in turn, will hand it off to our other panelists for their brief introductions. And while we're doing these intros, please take a second to respond to our second poll question, asking you about what industry sector you represent.
Hello, everybody. My name is Brian Conrad, an Energy Education Coordinator at Prince William County Schools. I hope to bring you the perspective of a building owner-operator who has successfully implemented these shutdown procedures. Glenn, turn it over to you.
Morning, everyone. So Glenn Anderson with the ETC Group. I've been an energy engineer for about 25 years, working here in Utah right now. Got a lot of experience in commercial, industrial, and military facilities. Right now, I'm going to, we do consulting, so I'm just bring some perspectives of, working with various clients and responding to the scenarios we have with the pandemic. Hey, Jim.
So I'm Jim Crockett. I'm also with ETC Group. I've been in the HVAC and the energy business for also around 20 to 25 years. And my perspective is recommissioning buildings, getting them to run correctly. And I'll hand it over to Chris Cox of Nexent.
Thanks, Jim. Hey, I'm Chris Cox. I'm the engineering manager out of Nexent's Salt Lake City office. I've been with the company for about 12 years. My perspective is where Nexent kind of designs and implements utility incentive programs. My engineering staff has been heavily involved in working with these companies on implementing some of these deferred maintenance items and helping them leverage utility incentives to do it in an energy efficient manner. Now I'll turn it over to Mike.
Good afternoon. Thank you all for being here today. My name is Mike Kelly with American Testing Incorporated. We are based out of Maryland, serving the Baltimore-Washington corridor, if you will. Today, I am representing the Associated Air Balance Council, also known as the AABC. They've been around for 50 years and counting, comprised of only independent testing, adjusting, and balancing member agencies. And we hope that our AABC perspective today will help everyone in their building shutdown and turn down scenarios, and will be helpful and informative to everyone. We certainly appreciate the opportunity. And again, we thank everyone for their time here today and immense efforts in getting us all together today. This is a milestone. So thank you again.
Thanks so much, Mike. And without further ado, let's get on to these individuals' presentations. We'll begin with Brian.
Well, good afternoon, everybody. A little more background about Prince William County Schools. We are located in Northern Virginia, just south of Washington, D.C. We have just under 100 school buildings, about 92,000 students, and an annual utility spend right around $23 million, plus or minus $1 or $2. I've been a part of the energy management and sustainability team for 7 years, at which time we've been able to save or avoid spending on utilities about $41 million during that time. So over those 7 years, we've had the opportunity to participate in lots of holiday shutdowns, summer shutdowns. So when this pandemic hit and we closed our buildings, we went and used those shutdowns as our baseline to go ahead and get into these facilities and get them turned down. What we normally do is we take these shutdowns and we distribute them to school staff members and students to perform the shutdowns. With them being out of the buildings, though, we turned to a different direction, and we worked with our other coordinators in facility services and asked them for some volunteers to go to these buildings and go ahead and get them shut down, since we didn't have the school staff members to do it. So as we were meeting with these other coordinators in facilities, we tried to come up with new ways, innovative ways to get some other things shut down that we normally wouldn't ask some of the teachers, some of the students to take care of. So we did, since we are shut down, the facility members are not required to go to the buildings or go to the office. So we did have to ask for volunteers, and got a tremendous amount of people interested in getting back into the buildings and helping us with this shutdown. We have split the shutdown into several different groups. And then with each one of those groups, we met remotely through lots of webinars and lots of trainings, explaining the different parts of the shutdown, what they would be responsible for, and which buildings they would be responsible for. And that took a couple of days to go through and explain that plan, explain those tasks for those different areas in the buildings. The next part is we wanted to, as coordinators, make sure that the staff was comfortable coming back into these facilities, because at this time we had been out for a couple of weeks. Buildings had been unoccupied and people had been sitting at home. So we wanted to make sure that we put together a plan and supported that plan with those individuals to put their minds at ease and their families at ease returning back to those buildings. So the first thing we did is we had a few key members of our team procure and create individualized bags of PPE and distribute those to those individuals that had volunteered. Again, just to give them a peace of mind going back into those buildings after not being there for so long. We created specific work orders for all those individuals with a specific task they were to perform at each one of those buildings, so they knew exactly what they were getting into and what they had to do and where they had to go when they were in those buildings. And then we also made all of the coordinators and foremen available for the days of those shutdowns, so that as the technicians were on site, they could call any one of us and ask us a question. Maybe they had an issue or ran across something that we didn't think of when we first handed out the plan and those tasks. Say, hey, what about this? And we could say, yeah, Absolutely, we can go ahead and add that to the list, share that with other members of the team, and make sure that was getting done at other parts of the building. So it was just a great feedback, a live feedback loop as we were performing each one of those shutdowns. Now, those shutdowns took us about 3 days to complete all 100 schools, and it takes us to where we are at now, which is the measurement and verification phase, which I will talk about in a little bit. So each one of those facility technicians had to participate either in a HVAC, kitchen, or general building shutdown. And again, they had specific work orders for those specific tasks for each one of those. Before I jump into those lists, though, a little bit note about the scheduling. About 95% of our buildings are scheduled remotely through building automation. So what we've done there, what we've done in the past, is we essentially put those into a summer schedule. And what that summer schedule consists of is we reduce outdoor air and those unoccupied spaces. And then we schedule a 3-hour dehumidification run every other day, just to make sure that we're maintaining those space conditions and those environmental conditions inside our spaces. On top of that, we have about 2/3 of our facilities with built-in dehumidification programming. So if we're monitoring a space humidity, if that space gets to 60%, it initiates or engages that humidity program, and it will run all that equipment until it drops the humidity down to 55%. Once it reaches that level, it'll go ahead and disengage, equipment will turn off, and it will go back and to the setback condition. So we feel that we have a pretty good coverage with our scheduling and dehum program to monitor and maintain those indoor air conditions. So for the specific task lists, don't feel that you have to write all of this stuff down. We will be providing copies of similar lists at the end of this presentation that you guys can download and take and use. It's very similar to what we have here. But I just wanted to point out a couple of things for what the facility technicians were doing as they went to these sites to shut them down. First thing there is we ensure proper outdoor damper operation. We wanted to go and make sure when that damper said it was open, and when it was closed, we said it was closed. They verified that with the building automation team while they were on site, and they fixed what they could while they were there, or they created a work order for that to be done at a later date. Not only is that great for maintaining our conditions now, but that is something when we reoccupy the buildings, we are pretty confident then that we've essentially commissioned a large portion of our outdoor air dampers. We also asked that the facility technicians pull the blinds up in the rooms where they could easily reach them. We do that to help increase the heat load in those spaces. As I mentioned, most of our spaces are controlled remotely through building automation and scheduling, but in areas like trailers, modulars, we have some standalone units, some standalone areas. We asked that those thermostats be changed to 82, fans on auto, and cooling to help maintain those spaces. And the last thing that those technicians did that were responsible for the HVAC shutdown, they ran by the cooling tower just to make sure it was functioning properly, make sure that the pits were full, we weren't running those dry, and also that we weren't dumping water, that those makeup water systems and floats were functioning correctly. The next section that we had a group of facility technicians perform a shutdown in was the kitchen. One thing that we're typically not able to capture in a normal summer shutdown, just due to summer programs, too much occupancy in the buildings, food prep, are walk-in refrigerations. This time we added it to the list. We were able to successfully consolidate and shut down about a quarter of our walk-in refrigeration units division-wide, which is something that we were pretty excited about because we haven't been able to do that before. Ice makers, I'll mention, nothing too exciting about an ice maker. Save a little bit of water by valving that off. Obviously, unplug that, drain it, clean it, save a little electricity. But the reason why I make note of it is because they can be found all over your facility, not only in the kitchen and food prep areas, but make sure you check all your athletic and administrative areas too. Indoor, outdoor concessions, training rooms, stadiums, finding ice makers all over the facilities. So, work with your staff and opening those doors in different areas and making sure that you can get things like those ice makers turned off. Also, because we're not doing the food prep and not washing the dishes, booster heaters for our dishwashers. Very easy to overlook those little electric units that are heating out water up to last 40 degrees or so before we do our washing on our dishwashers. Very easy just to flip the switch on those and get those turned off, and no harm in doing so there. And then something else here, but the exhaust fans and hoods, you actually see the exhaust fans on every single list. We do have a lot of bathroom exhaust fans. We do have a lot of standalone exhaust fans that aren't tied into the automation system, and particularly those kitchen hoods pulling out a ton of CFM. We don't want those running on a standalone program or just a switch on a wall where we end up creating a negative pressure in space, and then we start pulling in this untreated and unwanted outdoor air through cracks in windows and through doors, making a potential mess of some environmental condition in those spaces. The last section here is the general building. So the individuals that were tasked with performing this list basically went everywhere else in the building. A lot of this is just normal plug load things. Again, nothing too earth shattering here, but I will point out things like TVs, VCRs, DVDs, any of the AV equipment. We note that it's where a ladder is not needed. Reason being is we want to be able to occupy these buildings just as quickly as we shut them down. As I mentioned, it took us about 3 days to get all 100 facilities shut down adequately. We don't want it to take any longer than that. We don't want to have staff members come back having to request a ladder, climb on a ladder, reach things, climb on things, put their own safety at risk just to plug something in or to unplug it. So we wanted to make sure that we saved, yes, but we wanted to make sure we did it in a responsible fashion, that it did not cause any damage or took any undue or unnecessary time reoccupying those spaces. Also make note here that computers and monitors, we asked those to verify that they were off and not unplugged. We have been able to implement with our IT department a remote shutdown. That allows our IT department alongside with us to monitor and remotely shut down or turn back on computers from our IT. And anytime that we have a holiday, a summer shutdown, and instances such like this, they need to push an update, they can turn them all back on, they can push that update, and when the update's over, they can go ahead and shut them down. This is a great opportunity for your organization to look at and work with your IT department if you do not have something like that in place. It's very, very, very valuable. Something else that we're not typically able to do is unplug water fountains. Again, in our summertime, we have so much occupancy in these buildings, it doesn't pay for us to go ahead and unplug those. And again, we're not asking them to rip apart the water fountain to unplug them. Just where those plugs are visible and accessible, they can walk through, unplug those, and save a little bit on those compressors running. And then lastly, something that maybe not everybody considers, and actually our great staff in the electric department came up with this, is when we exited the buildings, we still had our time clocks for our site lighting in our parking lots set to winter hours. We have about half of our school division on photo cells, but the other 50% run on time clocks. So our electricians were able to come up with this idea and go around, and they set these back to summer hours, and we're able to spend about 5 hours a day per site on our site and parking lot lighting, which we think will add up to some pretty significant savings. And that takes me to the last part of the presentation here, these weekly building checks. Maybe the most important piece in my eyes and in our school division's eyes. This is what I refer to as a measurement and verification, that everything has been shut down and everything is running the way we do want it to run. Our facility technicians are visiting each site once a week. During this time, they'll be doing a general building check, but they're also monitoring indoor air quality. They're checking specifically for temperature, humidity, dew point, and HVAC status in 7 prescribed areas and a handful of other areas that they select in different HVAC zones throughout the school. Those 7 prescribed areas, just based on our experience over the last handful of years in our shutdowns and the materials that are kept in those areas, we know they're a little more susceptible to and a little more sensitive to environmental changes, too much heat, too much humidity. So not only are we monitoring those through building automation, we're also monitoring those once a week, boots on the ground, so we can verify everything is functioning correctly and those materials and equipment are safe in those areas. As I mentioned before, yes, we do want to capture savings, but by no means are we mothballing these facilities. We want to maintain the integrity of our spaces, the materials in those spaces, and the equipment running those spaces. Again, so when we can get back into those spaces, we can do so with very little issue or very little trouble, and then not cause more environmental issues than we had when we left. They're also going to run through some big bathrooms, mechanical rooms, cooling towers, checking for leaks, running water, proper mechanical operation. And then just as they're in those mechanical rooms and bathrooms, we ask that they check toilets, check traps, make sure they're not running dry. If they could go through and flush toilets, run some water down the sinks and in the floor drains, help reduce those smells and insect infestations. Again, trying to limit the amount of emergency calls or work we have to do when we return to occupying these buildings. So I thank you for your time. If you have additional questions or further questions that we don't get to today, specifically for me, at the end, please reach out. My email will be available. I welcome any calls or emails to discuss this shutdown or energy management program more than we covered today. So with that, Ed, I thank you very much, and I'll turn it over to you.
Okay, thanks a lot, Brian. That was an excellent presentation. We're not going to let you get away just yet. We've had actually several questions come in regarding the blinds. Let's just begin with one from Mark. What is your driver for pulling the blinds up?
Yeah, absolutely. It's a great question. Now, in Northern Virginia, we get high heat, high humidity, typically from middle of May through sometime in October, though it's only about 50 degrees today, so you wouldn't know it. But with our environmental conditions and climate, and then with our mechanical equipment, we have lots of central plants, lots of cooling towers, and those chillers work much more effectively and efficiently against a heat load. These buildings are unoccupied. So what we've been able to do over the past several years is we ask those blinds to be pulled up, allow the sun to kind of heat those spaces up, warm them up. So when we run our dehumidification programming or our dehumidification schedule in the middle of the afternoon, those spaces are really warm, so that chiller has a load to work against and can effectively move moisture out of those particular spaces that we're running those in.
And I'm sure we'll have you back with more questions. At this point in the webinar, let's turn it over to our engineers from ETC.
Hey, thank you, Ed. Hey, Brian, it's really cool to see how quickly you guys were able to put a plan together and jump on it and actually make some positive changes for your facilities. Jim and I are going to take a little bit of time right now. There's a huge amount of overlap between recommissioning, monitoring based commissioning, and honestly, what sort of things you could do now. And I think that's somewhat of the flavor of what we're going to talk about is now a lot of people actually have some extra time on their hands that maybe now's the time for them to be thinking about, well, what's something I've always wanted to do. And so we're going to run through some quick tips, things we've seen be effective. So, first thing is it's always nice to know what kind of energy are you using. So this is an example of a facility. We were monitoring the power in the facility, and it's 250,000 square foot building, and this is actually a cancer center associated with a medical facility, and at night its energy use was staying up at 370 kW, and this was actually a fully unoccupied facility. So, got us thinking, why is there so much energy being used in this building? And, that's sort of, first question is always like, okay, well, is it the HVAC? Well, we had the luxury of actually having the fan power being measured, the whole chiller plant. And so, only 50 of that kW is actually from the HVAC system. The rest of it was all, we didn't actually know. So that sort of led to let's do a walk around. And just always a question. I see a bunch of the questions that were going over to Brian about, well, how much is that costing? Well, even with the off-peak electric rates, fairly low, around 5 cents for this facility, this was wasting $8,000 a month, which is up to $100,000 a year. So they led us to say, let's do a walk around. What is going on? And we're actually quite surprised to see what we found. Going by the cafeteria, see, all the registers on, the number of things that Brian was talking about of, finding the various plug loads. That's what we were seeing. Then we were walking around, continuing to saw a lot of the common area lights were being left on. And, this was a new facility, and, they definitely had switching that enabled them to turn off a lot of a lot of lights. And what we actually learned was that there was actually a nice master switch. It was like, if you remember back in the days, you always had that janitor that had that key you plug into the wall and it would shut off all the lights. That's what they had, but nobody actually had the key. So all these lights were staying on. Another sort of carry through is like, what is going on in your building? This is one where, nighttime, this is a full month of electric data for all the air handlers in a building. And if you see, normally if you first glance, you're like, oh, yeah, they are scheduling really nicely. Well, actually, these little dips are weekends. So yeah, they were scheduling things off on the weekends, but during the week, everything was staying on. And this gave it the chance to start asking why, what was going on. And the situation here was the cleaning crews. Cleaning crews are coming in at night, and the quick solution was like, well, let's just keep the HVAC running all night, so it's not stuffy while they're in there and working. And the reality is now's the time to take the time, to dig in and let's put in something that's going to work. Maybe it's putting in an override button, so when they show up, they got the HVAC running, or you have it scheduled. There's a number of solutions that can come up, but this is. These are the kind of things that take the time to find out what's going on now. With that, I've given some, real quick, high level. I'm going to pass it over to Jim. Jim's got a little bit more brain power for digging into specific systems, and he'll be talking about what to look on specific systems.
Okay, so someone asked the question, what about BMS optimization for energy savings? And we may owe them some money at the end of the presentation. That's a perfect segue for what I am going to talk about. So if you have idle personnel or people who are, one of the common complaints as Glenn mentioned, is that when a building is operating, your staff is usually swamped responding to hot and cold calls. So during a shutdown, you may have time to actually do some of the stuff that you should be doing all along and probably would be doing if you had time. So I'll run through some quick examples here in this presentation. One of them is just go through the building automation system and look for things that are not as they should be. So for example, in these screens are going to show some of the stuff that we have found and commonly find when we're walking through buildings. Supplier temperature set point overridden down to 45 degrees. There was probably a reason for doing that. Take it back to 55. If it's a moderate day and your chilled water valve is 100% open, find out what the underlying cause is. You actually have time to investigate. If it's been overridden to 100% open, then release the override and then wait for the underlying cause to emerge. Dual duct. I get it. I may be the smart one. Glenn's the funny one. We have two ducts, dual duct. Get it? Anyway, Cinco de Mayo. He's in a mood. So with the dual duct system, what you want to do, just for the benefit of everyone, a dual duct system is similar to a VAV system. You have two sources of air. You have a hot source and a cold source. You have a hot duct and a cold duct, or duct, as Glenn calls it. And you use dampers to mix the hot and cold air to achieve your desired supply air temperature. And you want those two temperatures to be as close to each other as you can set them. 52 and 110 it's way too wide. Your cold deck temperature shouldn't be lower or much lower than your coldest supply temperature, and your hot deck shouldn't be hotter than your hottest temperature. Next slide, condensing boilers. Now, condensing boilers, in order for them to actually operate as condensing boilers, the return water temperature has to be colder than the condensing point of flue gas, about 135 degrees. If the water returning to your central plant is not 135 or lower, you don't have a condensing boiler, no matter what it may say on the nameplate. You simply have an expensive boiler. Now, if you don't know why the temperature coming back is above 135, I don't have time to get into it today, but it's fairly quick. Shoot me an email if you're dealing with that particular issue. Our contact information will be available, and I'd be happy to take a minute to respond. Fan coils, heat pumps, other small units, go through and make sure that they're not running. Make sure they're cycling. We'll find some of them that are, in mode 1, that are running continuously during the shutdown when it's just absolutely not needed. VAV boxes. Now is a prime time to go through and check your VAV boxes and make sure they're working correctly. As you know, it's all too common for actuators to slip on the shaft, for VAV boxes to get stuck open, to be stuck closed. And now's a good time to go through and check those. Stroke all of the dampers open and shut. Stroke the hot water valves open and closed. And also, or if you want to turn the system on for a day and watch it run, look for the odd man out. Look for a VAV box that's behaving differently than the rest of them, especially if you have control strategies that respond to VAV positions. So for example, if your supply air temperature resets based on what the dampers are doing, look out for those rogue boxes that are doing their own thing. See if you can find the underlying cause. So for example, you might have I've been in a lot of buildings where you'll have a VAV box that is never less than 100% open. Why? Well, because after the building was built, they loaded that room up with computer equipment and it stayed 100% open the whole time. And then when they implemented a supply air temperature reset strategy that was based on VAV damper position, it forced the supply air temperature to go to its minimum and stay there. Why? Well, fundamentally, you have an air handler supplying cold air because you have an undersized VAV box. Look for those types of things. If you have questions about those types of things, let us know. One other one that I don't have a slide for is if the chilled water, if you have a decoupled loop, and by the way, if this doesn't mean anything to you, tune me out. If you have a decoupled chilled water system and your secondary loop differential temperature, in other words, if the temperature of the water, temperature difference between the water leaving your central plant and returning is less than, let's say, less than 8 degrees or less than 10 degrees, then you're bypassing cold water, wasting pumping energy, and potentially having extra chillers on that aren't needed. You've probably got a problem with the coil. Something is happening. It's fairly easy to track that down. Don't have time to get into it today, but again, if you have that issue, if the differential temperature of the water leaving and returning to and from your central plant is small, it's worth looking into. As with other stuff, feel free to shoot me an email afterwards, and we're happy to provide help if we can. Contact information is available. Ed, back to you.
Before we let you get away, we have a question that's come up that I think is relevant, and indeed was directed at you, Glenn and Jim. This comes from Tori. Do you have any suggestions for how to minimize energy use while significantly increasing the outdoor air changes in a building?
That's that can be a bit of a challenge, but here's how I would respond to that. Because generally, the more outdoor air you have, the more energy it consumes. One of them would be to bring in outdoor air when it's cool outside. Wait until after hours. Don't do it at 2 in the afternoon. Do it at 2 in the morning. Have a nighttime purge, for example. That would be one way to do it. If you're stuck and you're just going to have to bring in outside air regardless of the conditions, and that especially if it appears that that's going to be a long-term condition, look at you're going to want to look at some heat recovery devices. Depending on the size of the equipment, maybe a air-to-air heat exchanger, run around heat pipe. There's different options. But basically, bring in air while it's cool, and if you have to bring it in when it's really hot or really cold, there may be a hardware solution that you have to look at. That's all I have.
Hey guys, while we are waiting for Chris and Mike to make a connection, I saw a couple of questions come through regarding some of the water, domestic hot water, and the hot water for our central plants. We made the decision in our division not to turn off our central plants or our domestic hot water. What we wanted to do is we just dialed the temperature back for our domestic hot water. We do have some custodial staff in the buildings doing some cleaning from time to time, nothing regular, but we wanted to make sure they had hot water as needed. We also wanted to try and prevent any issues from leaving that water get cold. So we just dialed the temperature back a little bit. So it's probably, depending on the facility, we dialed it back between 100 and 120 degrees. And we have circulating pumps. Most of the time, they're small 0.5 horsepower to 1 horsepower pumps. We just left those engaged and running as well, just to keep that water moving and that water warm enough to help reduce any issues with any environmental concerns there. The only central plants that we did turn off was our hot water boilers, and that was only at about 6 sites. Because of those 6 sites, we don't have dehumidification programming available. So there we turn off the pumps, the hot water, the whole kit and caboodle. And our regular maintenance in terms of our chemical addition to both the chiller plants and the hot water plants is still ongoing behind the scenes as we go through it with this shutdown. So we didn't stop doing that. So whether we were using the plants or not, our normal chemical treatment is still going on.
While we continue to wait for others, I did see a couple of questions out there that I could take on. One of them was talking about it's a combination of 2 things on the dual duct system that Jim was talking about. One was relation to duct static pressures, and definitely that is something to pursue, is getting the correct set points, because definitely doing a duct pressure reset will allow the fan BFD to back down. So I think Jim was pointing out that if you see that BFD at 100%, that's usually a sign of a problem. And then the other piece to that is, if you actually, some of the recommendations Jim was talking about was a lot of times if you have too hot a hot air and too cold a cold air, you end up delivering more air than you really need. And if you bring those airs in together, they're not going to have to fight each other. So those are the kind of things that will reduce the amount of air going out that will allow the VFD to back off. So with that, I think I am seeing that Chris is ready to jump and move forward.
Appreciate that, Glenn. Yeah, sorry about that. I had technical issues getting the slides up. Yeah, so my presentation is going to be just kind of a quick and simple way to use energy data or historical energy data to verify your shutdown procedures made an impact at the meter. Before I jump into this, I'm going to give a brief timeline of the pandemic in the U.S. Mid-February, we had that Diamond Princess cruise ship we all heard on the news. There were 39 U.S. nationals infected. March 1st, we had New York recorded their first case. Oregon recorded second case. There was a total of 62 cases in the U.S. By mid-March, social distancing ordinances were enacted. Schools began to close. Major sporting leagues suspend seasons. March 20th, California, New York, Illinois led a statewide non-essential workplace closure that occurred across the U.S. I kind of view this as this was our opportunity as energy professionals to act. So I'm kind of saying, this will vary between location, sites, but for the most part, what I'm seeing across the country is March 20th would really kind of signify a time when we should be making our shutdown procedures kind of public, pushing those, and we should also be starting those shutdown procedures. So March 20th is kind of that going forward. Let's notice that impact in energy at the meter. Where next it kind of gets involved with all kinds of organizations, from a small service station up to a large university campus, just kind of helping with utility incentives and the such, and getting involved with projects, leveraging the incentives to move them forward. This is just kind of what I've been observing in the last few months here. So for most organizations, there's been general guidance issued for shutdown procedures. And another thing I'm noticing is buildings are not mothballed, but set in a ready status, just like Brian mentioned. We're not mothballing buildings. We want these buildings to be ready when it's safe to do so. Another thing I'm noticing is walkthroughs are very common. This can be a daily walkthrough, a weekly walkthrough. And what these folks are in the buildings looking for, they're looking for maybe a potential break-in. They're making sure no pipes have burst, no water leaks. Maybe, if it's a high humidity area, maybe some condensation on the walls and such. So, these people are ready to have these buildings, active again. This is definitely not a mothballed status. Another thing I'm seeing that's kind of unusual is there's a challenge in the commercial real estate space with regards to lease obligations, intermittent occupancy, and essential equipment operation. These buildings have had a harder time shutting down. That said, Hatch Data released a study a couple of weeks back saying that, at least in their portfolio, they're saying that national consumption has declined by 22%. And that's encouraging considering these hurdles that these CRE space, these CRE space is faced with. Another thing I'm seeing is this pandemic occurred during a temperate shoulder season, meaning we're coming out of our freezing cold winter temperatures, and we haven't quite made our blistering hot summer season. This is more of a mild time. So what I'm seeing, at least in my region out in the Western US, a lot of the retail spaces are actually shutting down their RTUs at the disconnect. They feel that they're at no risk of freezing. They're at during the walkthroughs, it's not too hot, not too cold. But they feel like it's safe to shut down those RTUs at disconnect on those retail spaces. Another thing I'm seeing is many owners are addressing deferred maintenance. We're seeing a lot of incentive applications for boiler tune-ups, chiller maintenance, cooling tower maintenance, damper and actuator repairs, building control maintenance, things like calibrating sensors, maybe starting to implement some more aggressive recommissioning or building control strategies. We're seeing a bit of that happening. We're actually been fairly busy with the downtime in seeing owners addressing this deferred maintenance. What I'm going to show here is just kind of a quick and simple M&V strategy to kind of ensure that your shutdown strategy is realizing savings at the meter. And this came about, I noticed, I'm looking at these two sites where we're going to start some recommissioning. And kind of as part of this, during a pandemic, not a great time to spare recommissioning, but we still like to kind of document a baseline condition or baseline energy consumption. So I pulled historic energy data on these two sites and noticed much different results. That said, they really were set up for success to have some fairly, impactful energy savings at the meter, but we just didn't get those results. So wanted to share that and maybe discuss a couple of items that I think are kind of causing that. So we have building A, it's a 70,000 square foot building, uses DX equipment, things like RTUs, chillers, mechanical compressors, things like that. Building B is a 110,000 square foot building, uses evaporative cooling. And why I point that out is for those that are not in a drier climate where evaporative cooling is used, what we see on the cooling load profile is we don't see a big uptick in cooling season energy. It's more flat. We don't just because we don't have those large mechanical compressors. Another thing about these two buildings is both of them have a BMS and an enhanced analytics platform. By analytics platform, I mean systems like SkySpark, Coppertree, as well as ETC Group's Building Fit platform. Both good examples of kind of this enhanced analytics platform that provides additional data beyond what a BMS provides. Shutdown procedures were provided to staff of both sites on March 20th. The general guidance was to set back HVAC equipment, turn off interior lights when not occupied, and unplug items that are not critical to operation. Building A actually achieved a 27% reduction in March, 50% reduction in April. Assuming that this shutdown would occur for 6 months, which they're expecting, this is more of an educational type facility. This expected utility cost savings is around $11,000 for the year, which I know they're going to need that come when we get to the other side of this thing. Building B, we had minimal reduction. Actually, we saw a slight uptick in energy in March and about the same in April. This is kind of a similar facility where we're expecting about a 6-month shutdown. The expected energy cost penalty here is somewhere around $13,500 for that, not addressing those shutdown procedures. So kind of what I pulled out of this, a few things. One is an enhanced analytics platform requires staff training or an implementer to be effective. Just because you have purchased the system with all the bells and whistles doesn't mean you're going to get the savings that you're really hoping for. This requires some user input, whether it be from staff or an implementer. Another thing, I think this is more just coming out of my 12 years of experience. Site operators are not identical. Some focus on operations and uptime. Others focus on energy efficiency. So don't really expect it's just going to be a universal implementation of the shutdown. You have different flavors of site operators. Some are all about the reliability. Some are about the energy efficiency. Maybe the better place to be is somewhere right in the middle, looking at reliability and doing so in an energy efficient manner. Kind of going back to tying this whole thing together, I think simple energy use comparison can be an effective way to kind of verify these savings happen. So, just everybody has access to their historic utility history. You can access your utility. You can access your historic utility history and compare it to your April. And wrapping all this up, what should we be looking for? All energy end uses are going to be impacted by a shutdown. Lighting, we're seeing 50% or more reductions. That's kind of a no-brainer in my mind. Lights being off during unoccupied times, that should be quite easy. I know it doesn't make up a huge amount of your end use, but realizing savings in that end use are kind of a given. Domestic hot water, kind of the same thing. 80% or more reductions if tank systems are set back. Domestic hot water, nobody's in the space. I'm not expecting these systems to be drawing a lot of gas or electricity for heating domestic water if those systems are in place. So it should be pretty easy to realize your domestic hot water savings. On HVAC, it's going to be site and location dependent, but I'd expect at least 15% or more. And in some cases, like the retail spaces I mentioned, where they're just shutting down the RTUs, that's 100% savings that should easily show up at the meter. Plug loads are going to be a little more site dependent. I'm guessing 25% or more there. And so all that said, based on all energy end uses are going to be impacted, I would expect at least a 20% or greater reduction in April. And that's kind of it. I'll turn that back over to Ed.
Thanks a lot, Chris. We have a question we'd like to squeeze in here for you. This is from Brian. I have heard references that adding humidity in dry climates can reduce the risk of COVID transmission. Do you have knowledge about this? And what could we do in our facilities?
Yeah, Ed, that is correct. I'm no expert here. You know, my background's more in mechanical engineering. But what ASHRAE has provided some guidance on is they indicate that 40 to 60% humidity has been shown to aid in the dissipation of infectious aerosols, meaning when somebody coughs, that kind of those airborne issues that happen with a virus outbreak is going to aid in that dissipation of the infectious aerosols. And it also improves the body's ability to fight viral infections. So absolutely, you want to be looking at keeping that in between that 40 to 60% humidity range. And where humidification systems are in place, kind of addressing, do you have knowledge about this and what can we do in our facilities? This may be as simple as just adjusting the set points to maintain humidity in this range. From an energy standpoint, I would say if you're going to be bringing in new equipment just because there's a site risk, I would say try to avoid the steam canister types. Be thinking about adding evaporative media or ultrasonic humidification system. And this really just applies to the dry climates where we don't have that outside anyway. So yeah, from a facility standpoint, let's just try to avoid those steam canister systems if we can. And that's it.
Good afternoon. Thank you all for being here today. We have great attendance. We've had some really nice, informative, interesting thoughts and opinions today and ideas on building shutdown and operations and turn downs. Also in the restarting of these buildings after they're shut down. So I'm going to get to it. In representing the Associated Air Balance Council today and the member firms, I'd like to offer a few ideas and recommended practices and procedures. So moving right in, during this building shutdown, AABC would like to recommend that tab measurement and documentation would be key to ensuring that your buildings are performing as designed through the HVAC systems and for your restart and energy efficient operations down the road. Topics will include tab documentation and usage as a resource for detailed system information for current and future operations, guidance for owners and operators in maintaining and operating the building for future efficiency. I know some of us probably refer to the tab report or documentation that we get to be the building Bible, or facilities Bible, if you were, to maintain where all the design parameters and documented values for operating equipment are recorded, and they should be used and implemented as a resource down the road. During a shutdown, it's important to know the building resource scenario. By that, we mean, is it minimally occupied for teachers and administration staff? Will it be very minimally occupied with just admin and maintenance only, no teachers, no students? Will it be vacant with zero occupants, basically a work from home situation? And they happen everywhere. We have many situations where, I know in the lower Midwest or South, in Houston, they have teachers are still going into the school and putting in their time in webinars. So, communicating with students that way. Other areas like what we're in, the Baltimore, Washington area, buildings are, shut down. Everybody is work from home. I believe Prince William County, like Brian said, they're basically empty and they have some maintenance guys going through there once or twice a week. So you got to know the scenario of the building, and each scenario has a specific use relative to its operating status. When these scenarios, what status do we want to run these? High setbacks, low setbacks, minimal setbacks, summer school or summertime operating setbacks. Those are all important things to know before you get to this situation where you're like, what status are we in? So it's good to sit down and bring those issues to light before these happen. Climate zones are also key factors. I know we had said something about humidities and temperature setbacks. Those two following statements there about climate zones, key factors, and the prevention of mold and mildew. They're considerations that need to be serious during shutdowns. You don't want to shut your building down and let humidity take over and mold and mildew become the four-letter word, if you will. We all know where we've been with those, and that's something we just don't need. Moving on, school facilities have many different types of systems. We all know about geothermal, VAV, VRF. Someone's discussed condenser water earlier. Maybe it was Brian. Treating your systems, making sure your condenser water systems are, filled, not dormant. We don't want to create another situation where we contaminate any kind of open air water system, and make sure it's treated. Each type of system needs to have a predetermined procedure for turn down or shutdown. Like I just stated, you don't want to leave these things in a state of, well, we just turned them off and shut the disconnect. Hope it's good when we come back. These things need to be tended to in a right light. You don't want to just leave an energy recovery unit running because that's how it was, and we believe it needs to run that way. That may need to be off. Geothermal units, same way. They need to be off, or they need to make sure they're operating at their required scenario and status. So from an air balancing standpoint, Associated Air Balance Council, water balance, hydronic balance, measurement and documentation to each of these types of systems is important for the current and future operations. We all know if you can document what you have now, it'll help you get to where you need to be in the future. If you don't document now, it definitely leaves a question, and that'll come up in the next slide. So one of the examples Brian said earlier was about outside air and shutting down situations. Discoveries will be made as to functionality, operations. Do these dampers operate? Don't they operate? Do VFDs match what the BAS said? Do control valves match what the BAS is saying? Oftentimes, those little things, VAV operations, it was noted earlier that find the oddball. Very good advice, because a lot of times the oddball will show you where you need to direct your team. So moving on from there, while full tab is not required, a run through of the system sequence is definitely recommended to document the status and functionality as is. This should provide that during building HVAC restart, when the question arises, like what I just said in the previous slide, we all know that question. Well, it worked before. Why isn't it working now? Hopefully those documentations and measurements will get you to hopefully assist in that corrective action process. AABC recommends measurement documentation of critical main set points, as we said in the paragraph previous, a run through of the system sequence. How is it supposed to operate? Let's record statics. Let's record pressure drops through coils. Let's record pressure drops through filters. Let's record pressure losses through pumps and heating pumps, chill water, condenser water. Things happen when you walk away from them, and leaving things dormant. It helps to know where we were before we shut these down. A complete run through, probably not necessary. Building's already been balanced once, hopefully. And we just need to get some key information. And the more information we get, the more helpful it'll be down the road. Developing an itemized checklist as to specific building operations, making sure nothing is overlooked. That way, when we get to these situation we're in now with a pandemic, or something else that may put us in a situation similar to what we're in today, or have been in for the past 2-3 months, it'll make us as ready as we can be. So with that, I will end my presentation. I know we went a little long today, folks, but had a couple minor technical difficulties. I thank you and everyone for getting us together today. So enjoy, and everyone be safe and healthy out there. Thank you.
Well, it's Ed Armstrong again, and I'd like to thank all of our panelists for their wonderful contributions to today's webinar. So with that, I would like to tell you all that within 48 hours of this, you will receive an email with a survey, a link to the recorded version, and then within a week, we'll be also sending out your CEU or LU certificate. Today's webinar was brought to you by ETC, the Energy Management Association, and Building Fit. We thank you all for your participation and urge you to please stay safe. Thank you.
Hey, if there are still some people out there, I think there's a few questions that we could tackle a few of them. Um, Brian, I know there's a couple of questions that you were looking at that you thought you might be able to address.
Yeah, absolutely. One of the ones that came up was about realized savings to this point for the school division. We are just about 100% shut down. So a lot of things that we are doing is because our buildings are unoccupied. The savings so far that we've estimated, and then now that we're starting to see as these utility bills roll in, is about 60% savings division wide now because of both the HVC scheduling and dehumidification scheduling we're doing, but also the setbacks and the tasks that the facilities technicians went out and performed at each of those sites. So I think that's we're right about 60% now, and I think that's going to, as long as the outdoor conditions stay the same, we think we're going to realize that at the end of it.
And Brian, I think there might have been a question or two asking where you were located, because I know people are all over the country. I think we even have some Canadians on.
Yeah, absolutely. So we're in Northern Virginia. It's just south of Washington, D.C. on the East Coast. So though today, middle of May, it's kind of mild. Usually we get very high temperature, very high humidity months of May through October. And then below freezing, single digits in the wintertime. So a little bit of everything.
And follow along those lines, Chris, I don't know if you could jump on real quick. I know there's a question out there asking where your buildings were.
Yeah, they're all in the state of Utah, so in ASHRAE Climate Zone 5B specifically.
And I still see we have, good 150 people out there, so maybe we'll go with a few more questions. There's one question I know that was originally steered towards me, but I know, Brian, you'll have some input on it. It had to do with the lights that were left on in the facility, and wondering if that was for a security issue. And and I know in the facility, in particular that I was talking about, they actually did have emergency lights, which is about a quarter of the lights. So normally that's what they would have wanted on, was just those lights, and been able to turn off the rest. And it was all about for the security purposes that, if people were walking through the building of seeing them. And I've also seen some other studies talking, people are about like a dark campus, and actually going dark makes it easier from a security purpose of seeing people walking around with flashlights in there. Brian, do you have anything with your school district in, what you guys do?
Yeah, absolutely. We've considered both, or at least discussed both. And for the interior lights, we do at this time, it's just emergency lighting that we have running. And then obviously as people come in to do the building checks, lights on in those particular areas. But the site lighting, the parking lot lights, the building lights, those do run from dusk till dawn. And we just try to mirror those time clock hours to match the lighting outside. But again, all for security purposes. Our risk management department feels more comfortable with the lights on the exterior of the building at this time.
Jim, have you seen any questions that were jumping out to you in here?
Glenn, I do see another one about some of the domestic hot water temperature questions again. We didn't turn those off for our domestic hot water. They're now set an average about of 110 degrees. The facilities technicians, as they're turning those up and down, we told them we don't want them to go any lower than 100. But we don't necessarily need them up at 120 degrees, or for the kitchens, we had those at 140. So right around an average of about 110 is where we like to keep those. And we do want that water moving. We don't want it sit stagnant. So we do have those circulating pumps moving water throughout each of the heaters and storage tanks that we do have, and throughout the building as needed. And not turning it down too low allows us to still use it for custodial purposes, making sure with proper cleaning techniques, the hand washing techniques, it still will kill any of the viruses or colds that exist.
Glenn, one of the questions that came in, it had to do with the dual duct system. They said it was running at 100%. Do you recommend running it at something other than 100%? And that's a bit of a trick question. It depends on a lot of times. The reason you have a dual duct system is because you're required to maintain constant air volume. And so if that's the case, there's not much you can do in terms of fan energy. And so the focus goes to the temperatures of the hot deck and the cold deck. What we'll often find when we go into a facility is it'll be a moderate 75-degree day. I was at a facility in Southern California, for example. It was 75 degrees outside, and their hot deck was 110 degrees, and they were using electric resistance heat to get it. And their cold deck was 52. And I looked at the supply air temperature going to the various zones, and the supply temperature was all between 62 and 68. And so they were mixing 110 degree air and 50 degree air to get air that was between 62 and 68. So our recommendation was raise the cold deck up to 60. If you're gonna mix it anyway, mix 60 degree and 70 degree air to get temperatures between 62 and 68 rather than mixing 50 and 110 degree air. So with the dual duct constant volume system, that's where your energy savings comes from. You may be stuck with a 100% fan run speed. So hopefully, if the person who asked that is still on, hopefully that helps answer the question. Glenn, back to you.
Yeah, and I'm definitely going to throw a couple other, make sure everyone reminds that we're going to have some references, that are coming out. So we definitely have the presentation slides. I know Brian has some handouts for the checklist, but there's also some of the ASHRAE guidance for, how to operate the facilities. We were definitely more focused on the energy impacts during the pandemic and what you could be doing for reducing energy, but actually how you should be running the building in relation to, a startup for the facility, maybe minimizing infection potential within the building. We want to steer a little bit away from that, but we definitely put some references in, both from ASHRAE, and there's also I would highly recommend one. There's a 45-minute presentation talking about humidity and the impacts of the relative humidity on infection rates. And, it's definitely something that would be worth watching. So with that, I don't know that I see a whole lot else that's come in recently. We'll stay on for another minute if anyone wants to drop one last question. Otherwise, I do, appreciate it. A lot of people have stuck around right up until the bitter end, and we enjoy spending this time sharing what we've done and what we know, and getting some really great questions from people. Guess we're ready to call it an afternoon, and I hope everyone has a good and safe day. Thank you.